Hi guys, in this video I'm gonna solve the test. There were two versions, so this is version A and this is version B. Let's start with version A. So since we have more terms on the left than the ones we have on the right, that means we actually need to find the name for these descriptions, right? So let's start with the first one. A program that transforms human readable code into machine code. That's actually a compiler, right? Such as when we issue the javac command, we're actually converting from .java to .class, which is exactly from human readable code to machine code. I will just draw a line here. Sorry. I will just insert a line. That's easier, right? So this is a compiler. Then, rules that precisely defines a sequence of operations. So that's an algorithm, right? That's like the definition of an algorithm. So you go here. Sorry, this is super slow. Then rules and semantic rules. So syntactic and semantic rules, that's already a programming language, right? For writing and executing a program. So that's a programming language actually. So a programming language is the set of those rules in order to write, or the rules to write a program. Graphic representation is I will just copy and paste this, is the flowchart. Okay, so there should be a flowchart there. Okay, that's faster. Then the empty space, remember, at the beginning of each line, that's called indentation. Yes. And the last one, the instructions that a computer follows, that's a program actually. That's what a program is, right? Okay. Here, well, you need to type one or a logical test here, or an operation symbol, an operation symbol to actually get inside this if, right? Because n value is 10 and you want to get the number 10 printed. So you do need this test to evaluate to true. So how can you evaluate this? Which operation will give 10 watt 5 will be 0? Well, 10 mod, sorry, 10 mod 5 equals 0. When 10 is 10, then 10 modulus 5 will be equal 0, and then we will print number 10. Here you need to check, well, we have a plus b, so remember from left to right, whenever we find numbers, if we find the plus sign and we have numbers on the left and right, it will make the arithmetic sum. So this will actually add 8 plus b, which will be a 6, okay? So just by making this, just by seeing this, we can know already that the correct answer is this one. Okay, because it's number 6 followed by the forward slash, followed by the equal sign, sorry, followed by number 2 here, and followed by equal sign, and followed by C, which is the division, and the division is 4 times 2, right? Divided by 2, sorry. Okay, we have a small truth table. So P and Q. Remember, the AND symbol will only evaluate to true when P and Q are both true, and false otherwise. So this will be true. Since we have an OR here, whenever this evaluates to true, this all will evaluate to true. So since the first one is P and Q and we know that's true, this is already true. Then here, false and false, this is false. We do need to check if R is true. And it is, so this is true. Then false or true will be false, so false, false here. True or false, false, or true, true. And then here, first we need to make the OR, Q or R, so this will be true here, and P, this will also be true. But then we are negating that, so this will be false. Then here, false or true, true, and false, false, negated, true. And then true or false, true, and false, false, negated, true. And here the last one is true, false or true, here, true, and true, true, negated, false. Okay? In this part, we have a declaration and an initialization of these int values, 1, 2, and 3. Then we're asking if r is greater than p plus q. So in this case, we are actually asking if 3 is greater than 1 plus 2, which it isn't, right? Because 3 is equal to 3. So we won't enter here, and we get to this else. And here we need to check this value. If r is less than p plus q, which is 3 is less than 2 plus 1, which it isn't, so we enter here. So we are just changing the value of q here, and now the value of q will be 2 times the value of r. Since we haven't changed r so far, q will be 6, and r, since we never changed it, we just used it here, but we never changed its value, the final value will still be 3. Here we want to check in Java whether the value of an integer variable x is in between ints 3 and 7, including them both. And we have to mark the answers. So this is not correct in Java, not correct in Java, not correct in Java. So we can skip all those 3. Here we have x is greater than or equal to, so it's including number 3, and x is less than or equal to 7, including 7. So this one is correct. Let me just put some filter. Here the symbols are on the wrong order, so this will be a compiling error. Here we have the OR symbol. No, this doesn't work because any number is greater than or equal to 3 or less than or equal to 7, right? Here we want to check that x is greater than 2 and not greater than 7. So this one is also correct. We are checking if the number is bigger than 2, so if you think integers, that's starting from number 3, and we shall not go over number 7. X mustn't or must not be greater than 7, okay? And in that case, it's including 7, and that's fine. And here, we are checking if x is not less than 3 or greater than 7, which is also correct, right? So this one is also fine, because if you will only get true values here when x is not greater than 3 or not smaller than 3 and not greater than 7. Well, it will only be valid for values 3 to 7, so it works. And here this symbol will result in a compiling error. Before going to the coding, let's review test B, which has some differences. So let's start here. Let me just copy one of these lines. Let me copy this one. And here we have different definitions. So here it says, well, this is the same as the other one. So this one is a compiler. Then we have the description of an algorithm that resembles a programming language with conventions of natural language. That's pseudocode, right? That's the definition of pseudocode. Then some instructions that a computer follows to achieve a specific result. That's a program. Okay. The graphic representation of the steps or processes is a flowchart. A construct made up of variables, operators, or methods that evaluate to a single value, that's a statement, right? Well, it's actually an expression. If you put statements are made of expressions. The actual evaluation is the expression, right? If you put statement, I could give you half a point here. The correct point will be expression. And then here we have a set of rules that precisely define a sequence of operation. That's an algorithm, right? And that's it. So it's a little bit different. Here we have the same question. So it's the modulus, the remainder. Okay. And here I did change something. I just changed this symbol. Okay. So here we want the subtraction. So a minus b. So this will be a 2. So this is the only correct answer already, right? because it's usually 2 forward slash 2, which is the b, equals to 2, which is the division. Yes? Okay. And then another truth table, I change a little bit, I think, the variables. So P or Q again, and if we have true or false here, we should also check this to check the and, right? So P or Q, this will be true, and false, this will be false. False or false, this will be false, and true, false. And so if we have false here, it's false already, right? False or true here will be true, and false, false. And true or false will be true here, and true, this one will be true. Then we have here the negation of Q and R. So when Q is false and R is true, this will be true, right? Because of this negation. So not true, this will be false, and false, false, or true, true. Here, false, not false, this will be true or true, true and true, sorry, true or false, this will be true as well. And then we have true, this will be false and false, false or false, false. And then here it will be true and true. Yes, because we are negating this, so this is true and true, true, or true, true. Okay. Here I change a little bit. As you can see, I put this. Remember, the semicolon ends the statement. Okay. So we have P, Q, 1, 3. We are checking if R is bigger than P or Q. So this will be false because 3 is not greater than 3. So we go to the else. We are checking if R is smaller than P and R, and it will be right because we are making a summation here, an addition. So of course this will be true. R, 3 is smaller than 3 plus 1, of course. So we enter here. So now R is 2 times Q. So R is, we haven't changed Q so far, so R will be 4. And then the else ends here. So because this ends here, this is kind of a new statement, and this statement will be evaluated. We don't really care if we enter the if or the else or this else, because that ended up here. And this is a completely new line that will be executed no matter what happens here. Okay? So this is not conditionated to nothing, so this will execute always. So Q, the final value of Q will be 2 times the value of R. And since R is 8, the final value of Q will be 8. Okay, since R is 4, sorry, Q will be 8. So that's the answer here. And here I think I made more or less the same thing. Yeah, but now I changed this to excluding both. So again, this is not Java syntax, so this is incorrect. And here you're asking if x is not greater than 6 and not smaller than 4. So this will be from values 4 to 6. Since we are excluding 3 and 7, this one is correct. This is not Java syntax. Java is greater than or equal to 3, no. And less than or equal to 7. So this will include 3 and 7, so this doesn't work. Here we're asking if x is greater than 3 and not greater than 6. So this will work as well. You should mark this one as well. X is minor or equal to, no, because we are including number 3 and number 7, so this doesn't work. X is greater than, no, because we will include number 3 here. This symbol is incorrect. X is not smaller than 4 or smaller than 6. This doesn't work, right? Because not smaller than 4 or not smaller than 6, any number that is smaller, greater than or equal to 6 will fit in there, but not the ones we want. So let me check this. Oh, I read it wrong. So x is not smaller than 4 or not greater than 6. And that's fine, right? We want exactly that. Numbers that are not smaller than 4, because we want to start in number 4, or not, but for example, if we have number 2 here, this will be true, this will be false, but this will be false. That seems to be, yeah, this one seems to be correct for me as well. So check it, and if you can find a number in between 4 and 7 that returns false here, then this will be incorrect, but I think it looks fine to me. Okay, now we can solve the code. Both texts were asked to perform the same, to solve the same coding exercises, so I will just make these ones. Okay, so in the first one, we are saying that the sound emitted by a cricket can give us a temperature, and then we are going to convert that temperature into Celsius, and depending on the value, display a state. So first we need to get the temperature in Fahrenheit. This is a formula, but this is in a minute. So this n should be the number of cricket sounds every minute. Then we divide that times divided by 4, and we add number 40. But the number that we are going to get is the number of sounds in 10 seconds. So we still need to multiply that times 6. So we have the expected cricket sounds in a minute, and then we can use this formula. Okay, so let's start by doing that. I've already created the first part, so we have just a scanner. This is simple stuff, hopefully. We want to enter the number of sounds emitted by the cricket in 10 seconds, and we are going to save that on the variable int s for sounds. Okay, then we need to get the temp in Fahrenheit. So we're going to get a double here. It will be F for Fahrenheit, okay? And the formula is this one. So N is our S, but we need to multiply that times 6, okay? And then we divide that by 4, and we add number 40. We really don't need any parentheses here, but just to be sure, I will add these ones here. So that's the temperature in Fahrenheit. And then let's get the temperature in centigrades, okay, with this formula, which is just that formula. Fahrenheit here minus 32 divided, times 5, and all that divided by 9. Yes? So that will be my temperature in centigrades. And then based on that, I just need a switch or a bunch of ifs and elses to get the state. So let me create this state. It will be an empty string to start, and then if the temperature, if centigrades, is greater than or equal to 50, then that state will be too hot. If it's not, then we need to check the next one, right? If we will check here, okay, it's not greater than or equal to 50. What if it's greater than or equal to 30? Then we got the next range, right? Which is this one here. Then the state is warm. Let me put it with capital W there. Else, and I hope you can see how I am building this in blocks, okay? So if it's not greater than or equal to 50 and it's not greater than or equal to 30, then, well, I still need to check if it's greater than or equal to 80. Okay, if it is, then the state is nice. Else, we still need to check if C is greater than or equal to 0, in which case state will be cold, I think. Yeah, cold. And if it's not, then you already know that the state is freezing. Yes, because if it's not greater than or equal to 50 and not greater than or equal to 30 and not greater than or equal to 80 and not greater than or equal to 0, then it must be below 0, which is this case here. Then with all that, we just need to print it somehow. So system out print line, and we want to print something like the temp is, so the temp is, then we want to concatenate the temp in centigrades. Let's put a grade centigrades here, or degrees centigrade, centigrade degrees, and a comma value, it's and let's just concatenate the state. So it will say it's either warm or too hot or whatever. Okay, and that should work. Let's just compile that. x1.java, it's the file. We have what? Yeah, the state can be not the state, but the centigrades, not the state. Yeah, that seems to fix it. So Java x1, and let's try it with the first one, which is if we have some examples, right? 5 times on 10 seconds, the temperature should be cold 8 grades, and yeah, it seems to be correct. If we have 35 sounds, then we are on 33 degrees and it's warm. Yeah, 65 should give us 58 degrees, super hot, 58, and 20 sounds should give us a nice 21 degrees temperature. Okay, for the last one, this was, well, it required a different approach. Let's go here. We need to enter an item's price and the paid amount, and then we need to get the change. Yes, calculate the change. This is just a subtraction. And then get the number of coins that we are going to use. And the approach to this is use the remainder, the modulus, and the division. Remember, when you divide integers in Java, you will truncate the decimal values all the time. So here we just need to calculate, let's put a double. Well, we are just going to be working on ints for this exercise. We could use doubles, but let's just use just ints. So this will be the change. The change is the paid amount minus the price, right? And now we already have the change, so we can print that out if we want to. Print line, oh sorry. Oh, and change, something like this, and we concatenate the change, and that's it. And then let's get the number of coins. So we are going to just use some ints, tens equals 0, so the number of numbers of 10 value, and then 5s equals 0, and then 1s equals 0 as well. Okay, so how do we get the tens? Well, it's not that difficult. It will be the number of times we can fit a 10 coin in this change. Okay, so it will be actually change divided by 10. If we cannot fit a single coin here, so if the change is, let's say, 5 pesos, 5 divided by 10 without decimals is 0, so tens will be 0. Okay, then after that, we need to know, after we have fit some tens if we could, or none of them if we couldn't, inside the change, we have to check how much do we still have after putting those tens in, or after giving the user back some 10 coins already. And that will be an int. It will be the remainder of tens, and you get that how? After you get that, well, if you think about it, it's actually the change modulus 10, right? So it's the remainder of this division, actually, what you are getting here. If you have 5 pesos, this will be 5 modulus 10, which will be the number 5, and that's the amount you still need to give. If you have, for example, if change is 12, well, this will be 12 divided by 10. This will be 1 point something, but remember we erased the decimals, so this will be 1. Yes, you have 110 coin there. And then if you want to check how much you still need to give to the user, you do 12 modulus 10, which will be the number 2. And that's the remainder after using the tens to give some change to the user. Then we need to do basically the same. So 5s will be the remainder, because that's what we have actually. So remainder tens divided by 5. And then we still need to get a remainder of 5s, which will be the remainder tens modulus 5. Okay? And then for the last part, we can already know the number of pesos, because that's the remainder 5. We already know that whenever you have a modulus 5, you can get values from 0 to 4. okay? And that will be the number of pesos you actually need to give. We already have it. So we really don't need to do int reminder 5. This could be already ones, okay? Let's try it out. Let's just print, how do I print it? Like number of tens and then an equal symbol. And then we concatenate the tens, right? And let me just copy that a couple of times because we want the 5 and the 1, and this should be 5s, sorry, and this should be 1s. And that should do it, okay? Let's try it out. Let's compile it. Java. Let's try it out. So let's try the first one. It's 84 pesos and I paid with, well, we have some enters here that we could erase if we just change this from print line to print, right? And here as well, or here and here. But yeah, okay. So the price is 16, 1 and 5 and 1, 10 and 5 and 1 makes 16, so it seems to be correct. Let's check it again with the next one. It cost 12 pesos and I paid with 20, no, with 50. So my change is 38 and seems to be correct, right? 3 from 10 and 5 and 3 make 38. Let's try this one. It cost 1 pesos and I paid with 100 bill. So that's my change, 9 from 10 pesos, 1 and 4 here seems to be correct. And then if it costs 6 pesos and I paid with 20, my change is 14, and so 0, 1 and 4. Yeah, okay, if you have any questions or comments, just send me an email and we see us on Tuesday for the partial grades and the next step on this course. Thank you very much. Have a nice weekend.